can start off this introduction to functions by some definitions. For the function y equal to f of x, the variable x is called the independent variable. Because it can be assigned any of the numbers in the domain. The variable y is called the dependent variable because its value depends on x. The independent variable is also called the argument of the function. All right, so I have an example right here, and we're going to be looking at this example. So if you notice here, the x's here represent the independent variable. So this x, and this x right here, these all represent our independent variable. Our dependent variable is going to be represented by the g of x. This entire thing right here represents our y. So this whole thing represents our dependent variable because its value depends on x. Depending on what you choose for x, that's going to determine the value of our g of x, or our y value. Okay, let's move on. For the function f of z is equal to 4z plus 7, evaluate the following. F of z plus 3. So whatever you see that's given to you inside the parentheses, you're basically going to substitute that in for our z over here. I'm going to copy down f of z right here. Every time I see a z in my function, I am going to replace it with z plus 3. So I'm going to put z plus 3 inside this set of parentheses, and I'm also going to put another z plus 3 inside this set of parentheses. Now we're going to simplify a little bit. I'm going to distribute my 4. So this is going to give me 4z plus 12 plus 7. I can combine some like terms here. I can combine the 12 and the 7. And that's going to give me 19. And that's it. That's all we can do. So my answer is going to be 4z plus 19. Let's go ahead and box that in. There we go. Let's go ahead to the next one. Okay, now we're going to find f of z plus f of 3. So one more time, I'm going to copy down my original function, my f of z. If you recall, let me just go back up here. My f of z, my original one, was right here. We're going to just copy it down here. So f of z is equal to 4z plus 7. I'm going to have to add f of z plus f of 3. I know what f of z is, but I don't know what f of 3 is. So let me go ahead and find f of 3. F of 3 is going to be 4 times 3 plus 7. So f of 3 is equal to 12 plus 7. So f of 3 is equal to 19. Now that I know what f of 3 is, I can add f of z plus f of 3. So I'm going to write here f of z plus f of 3 is equal to, I'm going to copy f of z first. Right, this is equal to this, so that's what I'm substituting for this one. This one's going to go first right here. So I'll just put like a little red cloud around this. And I'll write it in red so it stands out. And then I'm going to write this plus sign right here. Now I'm going to put f of 3. F of 3 is equal to 19. So I'm going to use a blue color to kind of highlight this. And I'm going to write in here 19. So f of z plus f of 3 is equal to 4z plus 7 plus 19 is 26. So here we go. That's our answer. And if you notice, this answer is not the same as our previous answer for the last problem that we did. So if we compare the two, oops, let me get out of here. I can see that these two answers are different. So that's going to tell me that if I've got f of z plus 3, that's not necessarily going to be the same thing as f of z plus f of 3. So these don't necessarily mean that they're equal to each other. So you shouldn't assume because you got the answer to one of these, it's going to be the same as the answer to the other one. Alright, let's talk about definition of domain of f. When only the equation of a function is given, we agree that the domain of f is the set of real numbers x for which f of x is a real number. The following three things are the only three things you need to worry about when finding the domain of the equation of a function. So number one, you need to worry about not dividing by 0. So I'm just going to write here that you can't divide by 0. You only have to worry about this occurring when you have variables in a denominator of a function. So if you don't have variables in the denominator, then you don't have to worry about dividing by 0. So for example, I'm just going to put a little example here. If you had something like f of x is equal to 1 over x, you would have to worry about dividing by 0 here. The restriction here for x would be that x is not allowed to equal 0, otherwise this would be undefined. So this would be an example of when you would have to worry about dividing by 0. You only have to worry about this happening if you have variables in a denominator. Number 2, you can't take an even root of a negative number. So this would only happen if you had something, for example, like f of x is equal to the square root of x. You can't have any negative numbers inside of a radical with an even root. Even root means this is even here, right? So sometimes we have something like a 4th root or a 6th root, right? These are even. This one, when you don't see one, there's an imaginary 2 for square roots, right? So even though we don't see it there, there's an imaginary 2 that when we're working with radicals, that shows us it's an even root. But we don't have to write it in if it's a radical that's a square root, right? That's still even. This would mean that our x would have to be greater than or equal to 0. So here, x has to be greater than or equal to 0 in order to show that it can't be negative. The third case, you can't take a logarithm of 0 or a negative number. Okay, so this doesn't always happen in all classes. I know that in my class that I'm teaching right now, we are not going to be working with logarithms, but if you go on to a higher level of math class, then some classes you will have to worry about logarithms. So I'm not going to give any examples for that one, but that's only for in the future. Some people might need to worry about that case if you are working with logarithms, but that's not going to be the case in my class that I'm teaching right now. So we're going to move on here. Find the domain of each of the following functions. Looking at the first function, I look at the 3 things that I was working with and I say, do any of these 3 things, is there the possibility of any of these 3 things happening? Number 1, right? Remember, I can't divide by 0. Are there any variables that are in a denominator? No, there's no variables inside of a denominator, so I don't have to worry about number 1. Number 2, are there any even roots, right? Do we see any radicals? No, I don't see any radicals, so I don't have to worry about number 2. Number 3, are there any logarithms? No, we'd know if there was a logarithm because it would say something like log, right? And it doesn't say anything like log or ln, so we don't have to worry about that one. So whenever you don't have any of these 3 things occurring, the domain of a function is always going to be all the reals, all real numbers. Now, we need to know how to write this in interval notation and set builder notation. You can't just be writing all real numbers, right? Especially if your professor is going to want your answer in interval notation or set builder notation. So let's start off by writing it in interval notation. To write the domain in interval notation, we're going to write the open interval from negative infinity to positive infinity. This is interval notation. And if we wanted to write it in set builder notation, then we could say the set of all x such that x is an element of the set of real numbers. So this would be an example of how we write it in set builder notation. All right, and always remember to box your final answers whenever you're doing these type of problems, especially when you're taking a test in my class. All right, the next problem. The next problem says f of x. Okay, so I did make a mistake here. There is a typo. We need to fix this right away. This z, it should not be a z. It should be an x, right? I said this variable, it should be the same as this variable, right? We were talking about this and we said that this represented our independent variable. And, well, our variable needs to be the same. So we need to fix this. They can't be different. So let's go ahead and fix this because I made a mistake on this handout when I made it. We're going to make this an x and we're going to make this an x. That looks pretty good to me. So let's look at our three options. Number one, can't divide by 0. I said you only have to worry about this when you have variables inside of a denominator. Do we have variables in the denominator? Yes, we do. This variable is in the denominator. Therefore, we do have to worry about division by 0. We're going to take whatever is in the denominator, the whole expression, and we are going to set it equal to 0 and we're going to solve for it. X plus 1 equals 0, minus 1, minus 1. So I'm going to solve for x. I'm going to get x is equal to negative 1. So if I were to substitute a negative 1 into this expression in the denominator, I would get 0. That's undefined. Therefore, this x equal to negative 1, this is a restriction on my domain. I don't want this value to be allowed. So we are going to say that our domain, this time I'm going to write the set builder notation first, is going to be the set of all x such that x cannot equal negative 1. Now, in order to write this in the interval notation, it might be helpful to have a graph. So I'm trying to see, maybe I've got some space down here where I can draw my graph. I think I can fit it right here. Here's negative 1. So this is basically saying that you cannot have negative 1. So I'm going to draw an open circle on my negative 1. It's basically saying I'm allowed to plug in any values over here, any values that are over here to the right, but I'm not allowed to plug in negative 1. So I'm allowed to have the open interval from negative infinity to negative 1 union the open interval from negative 1 to infinity. And this is going to be my answer in the interval notation. Okay. So don't forget to box in your final answers. And I'll say or, either or. This represents the set builder notation, and this one represents the interval notation. Okay. The speed v of a car as a function of the time in seconds for the first minute after acceleration is given by v of t is equal to 5t. Identify the independent variable and the dependent variable. And then b, what is the domain of this function? Let's start off by identifying the independent and dependent variable. The independent variable. The independent variable is going to be t. So you could substitute values for t, and then you would end up getting values for the speed, v. So v, the speed, depends on what you choose for t, the time. So I'm going to write here my independent variable is going to be t, or time, right? In seconds, if you want it to be very specific. Our dependent variable is v, or the speed. Now they didn't specify what the speed was here, so I'm not going to write down anything for the speed, like the unit of measure. I'm just going to write v, speed. That's our part A. Our part B, what is the domain of the function? Now notice here that it says here that it says for the first minute, the speed v of a car as a function of the time in seconds for the first minute after acceleration is given by v of t is equal to 5t. It's only for the first minute after acceleration. So I'm going to write here for the first minute. I'm going to underline it. I'm going to set this domain equal to the closed interval from 0 to 60. So what does that represent? The 0 to 60, it represents, remember, we said the independent variable, t, is our time in seconds. Because there are 60 seconds in a minute, and it said it was for the first minute, that's why I'm doing the closed interval from 0 to 60. I can also represent this in set builder notation by saying the set of all t such that, remember we're going to put our smaller number first, 0 is less than or equal to t, and t is less than or equal to 60. Okay. The next problem. The function r of p is equal to negative p squared plus 200p represents the daily revenue r earned from selling MP3 players at p dollars for p is greater than or equal to 0 and p is less than or equal to 200. Identify the dependent and independent variables. Let's start off with that part A. So for part A, I'm going to write down independent first. My independent variable in this case is going to be P. So let's go ahead and write P, and I always like to describe it a little bit what our P represents. In this case it says that P is, it's basically the price that we're selling the MP3 players at. It says right here, from selling MP3 players at P dollars. So I'm just going to say price of MP3 players. And this is in dollars. Our dependent variable is going to be the R or in other words, our daily revenue. So I'm going to put here dependent variable is equal to R, which represents our daily revenue. And because revenue is measured in money, in dollars, you know, since that's what we're charging for the MP3 players, we're going to earn dollars. Does mean dollars also. All right, part B, evaluate R of 50. Provide a verbal explanation of the meaning of R of 50. So I'm going to copy down my function. R of P is equal to negative P squared plus 200P. But I want R of 50, so I'm going to substitute a 50 every time I see P. Alright, so let me check and see what this comes out to. I'm going to go 50 squared and I got 2500. So R of 50 is going to be equal to negative. Remember, it has to remain negative because the negative is outside of the parentheses. The negative is not being raised to the second power. So we need to make sure we maintain this value here. Negative 2500 plus, I'm going to multiply 200 times 50. That's going to give me 10,000. And that's going to come out to 7,500. Now remember what this represents. This represents dollars. So you're going to want to make sure you remember that this is dollars. When we explain the verbal explanation, that's going to be important. So I'm going to insert a little bit more space here. That should be enough space. I'm going to write here for our verbal explanation, if MP3 players sell for $50 each, then there will be $7,500 in revenue. Doesn't have to be perfect, just get across the idea. C was asking us to evaluate R of 120 and to also provide a verbal explanation for the meaning of R of 120. So let's go ahead and do that. I'm going to copy down my formula here. My function R of P is equal to negative P squared plus 200P. I'm going to write R of 120 is equal to negative, and then I'm going to make sure I put the negative outside the parentheses. I'm going to raise the 120 to the second. I'm going to go 200 times 120. And this will give me a negative. 120 raised to the second power is 14,400 plus 200 times 120 is going to give me 24,000. And if I add those two together, I get 9,600. And remember that we are talking about money. So I'm going to put a $sign. And then when I give my verbal explanation, I'm going to say if MP3 players sell for $120 each, then there will be 9,600 or $9,600 in revenue. Now, I want to remind you, it's very important that you box your final answers. So I'm going to go ahead here and box my final answer here. Right, they were also asking us to find this and find this. There, I think I've boxed everything in. It all looks good. Excellent. Good job.